Let's recall the power rule for differentiation. As we remember, the derivative of x to the power of n is n times x to the power of n minus 1. Now we want to formulate a similar rule for the integral of x to the power of n, and we'll call this the power rule for integration. So consider the integral of x squared dx. Now we basically want a function whose derivative is x squared. So a good guess for a function whose derivative is x squared would be x cubed. But as we notice, the derivative of x cubed is 3x squared. We unfortunately have this 3 over here. Since we don't really want this 3, what we can do is divide both sides by 3 or multiply by 1 over 3. What happens now is that the right hand side becomes x squared, and the left hand side we bring the 1/3 inside the derivative. The left hand side becomes the derivative of x cubed over 3. And so we can see that the derivative of x cubed over 3 is x squared. Therefore, the integral of x squared dx would be equal to x cubed over 3. And let's not forget plus c. Performing a similar analysis for x cubed dx, we know that the derivative of x to the 4 is 4x cubed. But we have this 4 coefficient on the x cubed, which we want to get rid of, so we just divide both sides by 4. What ends up happening is that we get the derivative of x to the 4 over 4 equals x cubed. Consequently, the integral of x cubed dx is going to be x to the power of 4 over 4 plus c. Now you can probably notice a pattern. Try to figure this one out on your own. Did you get x to the power of 5 over 5? In general, we can say that the integral of x to the power of n dx is x to the power of n plus 1 over n plus 1 plus c. Let's use some examples to apply this formula. Integral of x to the power of 100 dx is simply going to be x to the power of 101 over 101 plus c. X to the power of pi. Now pi is just another number, just like 100 or 2 or 3 or minus 5. So the integral of x to the power of pi dx is going to be x to the power of pi plus 1 all over pi plus 1 plus c. Integral of root x dx is nothing but the integral of x to the half dx. Applying the power rule, we get x to the power of 1 over 2 plus 1, which is 3 over 2, all divided by 3 over 2 plus c. But it might be more convenient to write this in radical form and without the fraction in the denominator. You know that dividing by 3 over 2 is the same as multiplying by 2 over 3. So we get 2 over 3 square root of x cubed plus c. The next example is very similar to the previous one. This is simply the integral of x to the power of negative 4 over 5 dx. And applying the power rule, we get x to the power of 1 over 5 all over 1 over 5, which is simply 5 times the 5th root of x plus c. As for our final example, we must not be misled into using the power rule for this one, because this would lead us to dividing by 0. For example, if I blindly use the power rule here, I'm going to get x to the power of negative 1 plus 1 all over negative 1 plus 1, but this is going to involve dividing by 0. And remember, we cannot divide by 0. Therefore, we do not apply the power rule in this case. Instead, we rewrite this as the integral of 1 over x dx. As you remember, the derivative of ln x is 1 over x, and so the integral of 1 over x is going to be ln x. So we get ln absolute value of x plus c. And here are some questions for you to apply the power rule on your own. The answers will be shown in a few seconds, so pause the video and try these questions out.